As we move on to 11.4, we're going to learn how to add and subtract these rational expressions that we've been dealing with. Again, factoring skills are essential to be able to understand this. We're going to talk first about problems that have common denominators, and then we're going to talk about problems that don't have common denominators. Main thing is always try to factor first. If you can't factor, then move on. Let's take a look at problem 1a. In problem 1a, the first thing I'm going to notice, I'm going to use the letter CD. And CD stands for common denominator. In letter A, we do have a common denominator of 3y. Well, just like in old school fractions, if you have a common denominator, it stays your denominator, and you simply add the tops. Now what you need to do is after you add 4 plus 7 is 11, you need to check if it reduces. Does this reduce at all? No. Does it reduce at all? No, this one doesn't reduce, so we leave it as it is. Now, if that was a 12, you would have to reduce everything. Let's move on to part B. Look at the denominators. There is a common denominator, so I'm just going to give it a check mark. And I'm going to add the tops. So I keep my denominator, x minus 2, and the top I'm going to do 3x plus x. And the next step, I'm just going to add my numerator together. So you get 4x over x minus 2. Then you ask yourself, does this reduce at all? The answer is no, this doesn't reduce. Okay, no on both of these. So you just stop. If you have to factor, and we might want to write that down, you may need to factor at end. And we'll talk about ones that happens at, but not quite yet. You might need to factor at the end. Take a look at the got it number 1. Notice there is a common denominator, so I'm going to give it a check mark. Common denominator is 3a minus 4. Now we have 2a plus 3a, which if you don't mind, I'm just going to put those together right away and get 5a. This doesn't reduce at all, so 5a over 3a minus 4 is your final answer. Moving on to problem 2. It says subtracting expressions with like denominators, or common denominators. So let's look at these. Do you see that we have a common denominator? In other words, that they are both the same? That's great. So what I'm going to do is I'm going to write a big fraction bar. I'm going to get 3x squared minus x minus 2 on the bottom because that was the denominator for both of my fractions. Now do you see this negative sign? I'll take this one slowly, okay? We're going to have 7x plus 5 minus the quantity, and this is where it becomes important. Those set of parentheses are essential because it's minus the quantity 4x plus 3. Now you might wonder, why are the parentheses so important? It's because this negative needs to be distributed, okay? So this is really, on the top, 7x plus 5 minus 4x minus 3. All over your common denominator of 3x squared minus x minus 2. Combine your like terms on the top to finish this problem. Okay, 7 minus 4 is a 3x. 5 minus 3 is a positive 2. Always check, does that factor? No, it doesn't. Now let's rewrite the bottom. Now on the bottom, at this end step here, just like I wrote up here, at the very end, you're going to see if you can factor. Alright, so look at the bottom here. Can you factor the bottom denominator at all? Well, let's check it out. If you do 3x and x, and you do 2 and 1, can you see how the bottom actually does factor into two different binomials? If that happens, you can go ahead and cancel if possible. So let's see, what did we just do? We factored, and now we're going to cancel. So 3x plus 2 cancels with 3x plus 2. Your final answer is a 1 in the numerator and an x minus 1 in the denominator. Let's move on. A couple more of these. We have another minus sign. So just remember that this is a negative 7 essentially. Common denominator, I can give it a check mark. The common denominator is z plus 3. And the top is simply 2 minus 7. So that gives us a negative 5 over z plus 3. That doesn't reduce or cancel or factor or any of those things, so we stop. Now in part B, what we're going to do is, again, we have a common denominator, give it a check mark. Okay, I'm going to write 10n minus 4 on the bottom. I'm going to write 9n minus 3 on the top. Now watch what I'm going to do on this one. So I can skip a step if it's okay with you. I'm just going to put my signs as if I were distributing this negative, okay? So I'm going to distribute my negative in here. So that's going to be a minus 3n minus 5. And you might wonder, well, what step does that actually save? See down here where I wrote it in parentheses? I'm just skipping straight to this step now, where I already distributed the negative in. So combine your like terms. 9 minus 3 is 6n. Negative 3 minus 5 is minus 8. And that's over 10n minus 4. Now you should always be able to see that these factor because they have those 3 letters by GCF. So let's look at the top and pull out a 2. 3n minus 4 then. And let's look at the bottom and again pull out a 2. 5n minus 2. Cancel the 2's. And your final answer is 3n minus 4 over 5n minus 2. Let's go on to part C. Notice again we've got our common denominator. I'm hoping that you see already that our common denominator will factor at the end here. We'll factor it in a little bit. I'm going to distribute my negative just like this. See how I changed the signs? I did a minus 6q and a plus 5. So the numerator is 7q minus 3 minus 6q plus 5. And I changed those signs because I distributed my negative. The top is a 1q plus 2. The bottom is a q squared minus 4. At this step, I'm going to factor the bottom because it's a difference of perfect squares. So I get q plus 2 over q plus 2, q minus 2. Difference of perfect squares, factors like that. Cancel the q plus 2's, and I get 1 over q minus 2. So we kind of have our steps, all right? We combine our numerators, we combine our like terms, we factor, and we cancel. Let's go ahead and do that. Combine numerators,